we got this going on here. Excuse me. Alrighty. So, okay. So, y'all, today, what we're doing, ask me. We're going over questions from the review, right? So the objective today, y'all, is whatever questions, whichever problems you were uncertain of how to do from the review, then the idea is we'll answer as many as we can in the time that we got here. And we got a whole lot of time, y'all, so don't worry about that. Go ahead, take your time. So let me see. Let's see if I can get a new. What's that page? Yeah, that's good. Okay. So anywho, are you guys good with question one? You want me to do question one? We're good with one. Okay. What about number two? Are we good with two? We're good with two. Yeah. All right. I'll tell you what. Are there any questions that you know you have already? Like eight. We're gonna do eight. Okay. Okay. So guys, before I get to eight, 3, 4, 5, 6, 7. Anybody? You want me to just kind of put them up here just real quick before I get to eight? So 4, we good? Yes, let's do 4. Okay, so let's do 4, and then we'll come back and we'll do 8. Okay, so just this way we're kind of going in order, you know. Okay, so let's take a look at number 4 here. And I'm just going to do a little copy and paste. So let's copy this, and then we'll definitely get to number 8 as well. Okay, so let's see here. It says a boat is anchored offshore. From the bow of the boat, 37 feet of anchor line is out with 4 feet of line above the water. The angle that the line makes with water line is 23 degrees. Oh, I didn't copy. Supposed to find. So what are we supposed to find? We're supposed to find the depth of the water. Okay. So let's do that part real quick, and then we will figure out what it is we're trying to do here. Okay. Let me copy this, come back over here, and what is the depth of the water? Okay, so let's see if we can't figure something like this out. Get my pen going. Okay, so y'all, I'm trying to find this value right here, right? And we know that our angle B is 23 degrees. Y'all agree with me that that angle right there is the same thing as angle B, that that's also 23 degrees? Okay, and since we are trying to find this value right here, we also know that the entire length of that line is 37 feet, and it tells me that 4 feet is going to be this part, so that's going to be 4. So would you all agree with me that if I do this, say in green, that green value is going to be 33? Would that make sense that it would have to be 33? If the whole thing is 37, and I know that, say, oh, come on, pen. And I know that, say, this part right here is 4, then that has to be 33, right? And if we're trying to find the, whatchamacallit, the depth of the water, right? Or the, yeah, how deep it is, that's the distance right there. What trig function can I use? Anybody know? Can I use sine, cosine, sine? So, yeah, wouldn't we say that the sine of 23 degrees is equal to the opposite, I don't know, I'm going to call it h, over the hypotenuse, which is 33? So then, yeah, sine of 23 degrees. Okay, so let me get my calculator going. First thing I'm going to do, y'all, I'm going to make sure that I'm in degrees. And right now I'm not. Yes, it's being recorded. Okay, so let me enter that there. Okay, let's quit here. So then we're going to go 33 sine of 23 degrees. And what I'm coming up with is 12.89, and it's telling me to go to the nearest foot. So I would say, yeah, 12.89 is going to be the same thing as 13 feet. So right here, I'm going to put 13. And what I'm going to do is I'm going to come back over here. I type in 13, and we're going to go chickadee check. Okay, so we got that part. Okay, so now the second part says, what is the horizontal distance between the anchor and the bow of the boat? Okay, so let's do this part here. Again, let me do a little copy and paste. And before I go on, are we good on how we did part A? Am I good on part A? Okay, just checking. Okay, so now it says, what's the horizontal distance between the anchor and the bow of the boat round to the nearest foot? Okay, so look, y'all, I'm going to come back here. I'm going to clean up some of this mess. And we're trying to find the horizontal distance between the anchor. So here's my anchor and the bow of the boat. So I'm really looking for that value right there. Okay, I still know that this angle here is 23 degrees. That we know for certain. And we know that the total distance from here to there is 37. And so if we're trying to find this value here in blue, what trig function could we use? Cosine, right? So wouldn't we say that, I'm going to just write this out, the cosine of 23 degrees is equal to the adjacent side, I don't know, let's call it x, over the hypotenuse, and the entire hypotenuse is 37, right? And so now we're going to solve for x, so we're going to say x is equal to 37 times the cosine of 23 degrees. And again, I'm going to grab my calculator. Let me do this over here so you can see everything. So 37 times the cosine of 23 degrees. And I'm coming up with 34.05. And I think it's still asking me to go to the nearest foot. So y'all agree that'd be about 34 feet if it was 34.05? Okay, excellent. So right here, we're going to type in 34, and we're going to go chickadee check. Boom, and we got it. Okay, good question, good question. Okay, so again, we're working our way to number 8. Anybody got any questions on 5, 6, or 7? Yeah, so let's do that real quick, y'all. Let me see. Let me come back over here. Here's our class. Let me see. I sent y'all an announcement with the info about test 2. So right here, y'all, here's the info about the announcement. Here's my formula sheet for test 2. And I'll tell you what I'm going to do. I'm going to open it up just so that I can have easy access to it. There we go. Okay, so let's come back and let's take a look at problem number 5. It says solve the triangle for the sides given expression for the exact length in terms of sine approximate to 1 decimal place. Okay, so let's do this. Let's take a screenshot here. Okay, so let me copy this here, and I'm going to paste this over here. And I'm going to come back one more time because, okay, so look what it's asking me to find. It's first asking me to find the value of little a, right? Okay, so hold on, we're going to go real slow. So first thing I want you to notice, it's asking me to find the value of a, okay, the little a. So let's take a look here. If I'm going to do this, do y'all agree that we could say something like, from the formula sheet, the sine of a is equal to b over the sine of b, right? And again, y'all, all I'm really doing here, I'm just going to pull this up, and I'm going to kind of scroll down. Let me see if I can find it. Here we go. Here's my law of sines, right? So I'm just saying little a over sine a equals little b over sine of b. Okay, so now that we have that, let's see if we can find our value of a. So this is going to be the sine of 40 equals little b, which is 42, divided by the sine of 102 degrees, right? Okay, so now I'm going to multiply both sides by the sine of 40. So this will cancel out. So we're going to get a equals 42 sine of 40 degrees divided by the sine of 102 degrees. And the first thing I want to do, I'm going to come back over here. I want you to notice it's asking me to find, and it has it right here, the exact value, right? So the exact value, y'all, is this part right here, okay? So let's enter that in. What is it? 42 sine 40 divided by sine 102. Okay. Oops, where did we go? Here we go. So 42 sine of 40 degrees divided by, oops, that's not doing what I want it to do. So we'll go like this. Let's do the fraction first. 42 sine of 40 degrees divided by sine of 102, right? And don't forget the little degrees. And then let's see what the approximation is, okay? So let me come back over here. And okay, so I'm going to do now my approximation, y'all. So I'm going to do this part on the calculator. So let me just move this guy over. So we'll go 42 times the sine of 40. So notice, y'all, on my calculator, when I'm going to type in my angle, it opens up parentheses. I'm not certain if yours does or if it doesn't, but if it does, make sure you close off your parentheses, okay? Divided by the sine of 102. And the reason you want to close out those parentheses is probably back in middle school somewhere, maybe 7th, 8th grade, we learned something called the order of operations. And if I don't close out those parentheses, it's assuming that all of that's going inside my angle, okay? And that's not really what we got. So I'm coming up with 27.6. Okay. So let me come back to my problem here, and we're going to type in 27.6. It says 1 decimal place, so that's what we're going to use. Okay, so then let's go ahead and chickadee check. Boom, we got it. Okay, now it's asking us to find the value of the angle C. How would you find the value of the angle C? Very good. Jennifer says, let's add up both those angles and subtract it from 180, right? So what is that, 142? 180 minus 142. And John tells me that is 38 degrees, okay? Right here, we're going to type in 38 degrees. We're going to go chickadee check. Boom. Okay, and now again, we're going to do the last part. We're going to find a value for C, right, little c. Okay, so let's come back over here. So we knew that this angle here, what did we say? That was 38 degrees? Okay, so we're trying to find, say, a value for little c. I might do something like this, y'all. I might say little c over the sine of 38 degrees is equal to little b over the sine of big B. And I would probably do it this way just because when we found A, we got an approximation, right? So I'll do it with B because B, we had all the values in. So C equals the sine of 38. And let's see, we had already done what B was. It was 42 divided by the sine of 102. So 42 divided by the sine of 102 degrees again. So one more time, y'all, we'll multiply everything by the sine of 38 degrees so we can cancel this guy out. And we'll end up with 42 sine of 38 degrees divided by the sine of 102 degrees. That's my exact answer. And let's do our decimal approximation. Let's move this guy over here. So 42 sine of 38 divided by the sine of 102. And if I'm going to go to 1 decimal place, 26.4. Okay. So here's my exact answer, and here is my decimal approximation. So 42 sine 38. So I'm going to do my fraction first. 42 sine of 38 degrees divided by the sine of 102 degrees. And that was how much? 26.4? So 26.4. And we're going to go chickadee check.
So that equation, 42 sine 38 sine 102 over sine 38, that would be little c over sine 38.
I'm sorry, say that again?
So that is an equivalent to little c, right?
Yes.
So if you were to write, so if I were to make the number that was given, 102 as the angle and 42 as the relative I were to put that, just get the estimation of whatever the number is, and then I put that equation equals this times 38, would I get the same number? Because it's equal, right? No. I'm asking if like they're actually like equal numbers. Like if you were to do the math,
Uh-huh.
that number is 42 plus 38 divided by sine 102.
Uh-huh.
All that divided by sine 38, which would be little c divided by sine c. That should be equivalent to.
So this is little c itself, right?
Yeah.
Okay. So you're okay, so ask me one more time so I can make sure I can understand what you're asking me to do.
I'm asking you, because like you're writing this, the log sign works because those numbers are always being equal.
Right.
Right? And so I'm asking you, if I were to put that number divided by sine 38, and then get the estimate, let's say it's like.
Okay, so if you were to write this number right here, right?
And then divided by sine 38.
Okay, so this is 42 sine 38 divided by the sine of 102. Okay, and you want to divide it by, excuse me, you want to divide it by the sine of 38 degrees? Okay, so you're going to divide it by the sine of 38 degrees. Okay, that's going to give you what?
It's going to give you 42.98.
Okay, but what's your, I'm trying to figure out what's your question though.
But that would be equivalent to if I were to get
To take the little b and divide it by the sine of b. It should work, right? So try it. So take 42 divided by sine of 102 and see if you get the same number. There you go. Yeah. Yeah. Yeah, no, you would get the same thing, right? And you could do the same thing with, what did we come up with for little a? We came up with 27.6 divided by the sine of 40. You should roughly get the same number, right? Because that's what the law of sine says, right? It says that this ratio right here, they're all going to be the same. Yeah. Okay, so good. Let's continue. Okay. Number 6. I want to get to number 8, y'all, because I know that's Jennifer's question, but I want to just kind of go in order so we're not kind of like jump around.
This is the same thing with the visualization, right? Okay.
Yeah, and look what it's asking me. So like, look, again, guys, there's no surprises here, right? So look what we have. We have the angle A, we have the angle C, we have little c. What's the first thing it's asking me to find? The side or the angle? Okay, so we know how to do that, right? Because we're going to add, like Jennifer said a little while ago, we're going to add them up, subtract it from 180, plug it in, and we're done, right? Okay, so I'll tell you what. Let me go to number 7. Let's see if it's the same type of problem. Okay, so 7 is asking me to figure out if we have one triangle, two triangles, or no triangle. Okay, so let's see if we can go through this one, and then we'll get to, Jennifer will get to number 8. I'm sorry? Oh, 8's the same kind? Okay, so I'll tell you what, guys, if number 8 is the same type of problem, boom, let's do number 8. Okay. Okay. Okay, so let's take a look here. So again, I'm going to do a little copy. I'm going to come back to my notes over here, and here we go. Let's do a little paste. Okay. So it says information is given about our triangle ABC. Determine if the information gives us one triangle, two triangles, or no triangle. Solve the resulting triangle or triangles and round the lengths of the sides and measures of the angles to 1 decimal place if necessary. Okay, so let's see what we got here. We have little a, little b, and angle A. So I'm just going to draw a triangle. I don't know what it's going to look like, y'all, but I'm going to do something like, something like that, okay? And we know that little or big angle A is 45 degrees. I have no idea what the angle B is. I have no idea what the angle C is. And I have no idea what the little side C is equal to either. But we do know that little a is 16 and that little b is equal to 18, not degrees.
We find out if it's a real sine inverse of this like number that you need to like equation, right?
Yes. So I'll tell you what. Let's go through it together, right? Let's just see if we can figure it out. Look what we're trying to find. We're trying to find the big angle B. We're trying to find the big angle C and the little side C. Okay. So look, y'all. I'm going to write the. Remember when we had the law of sines? We could also write it like this, like the sine of big B over B is equal to, what do we know? We know A and little a. So we can say the sine of the angle A over little a, right? Okay. So we're going to start plugging in. Sine of big B over little b, which was 18, is equal to the sine of 45 over 16. Okay. And so everybody agree we're going to multiply both sides by 18 to cancel that business out? So we're going to say sine of b is equal to 18 times the sine of 45 over 16. Okay, before I go on, are we good up to this point? We're all good up to this point? Okay. Do you remember how we're going to find the value of b? How do I get rid of my sine inverse? Excellent, good. So b is going to be equal to the sine inverse of all this business right here. Okay, so y'all, I'm guessing at this stage of the game, because y'all in pre-cal, right? You're pretty comfortable with your calculators. So again, just be careful with it, right? So last night, y'all, I was in my college algebra class and we were talking about logarithms, and I don't know how much you guys remember about logarithms, but some people kind of struggle with the concept, right? And as we were doing the problems on logarithms, I was telling everybody, just be real careful how you enter in what you're punching in the calculator, because whatever comes up on my screen is la palabra de Dios, right? It's the word of God. You don't ever question, is this right or wrong, right? It's just, that's what the answer is. But if I accidentally hit the wrong number, then I'm going to get the wrong answer, and I had no idea why, right? Because I believe that's what the answer is. So just take your time with it, okay? So look, we're going to go second sine inverse 18 times the sine of 45 degrees, close off those parentheses, divided by 16, and then close off the parentheses for my sine inverse, and I'm going to hit equals. And I'm coming up with b equals, what, 52.7? And are they asking me to do any rounding here at all? 1 decimal place, okay. So we're coming up with b equals 52.7 degrees, okay? All right, now that we found that, so we have our b, which is 52.7. Right here, y'all, I'm going to put 52.7, okay? Now, we were going to find our value for angle C. So for the value for the angle C, y'all agree we're going to take 180 minus A, which was 45, plus B, which we just found to be 52.7? Okay. So let's see what that's going to be equal to. So I'm going to go 180 minus whatever 45 plus 52.7 is. Okay. And that's giving me 82.3. So this right here, y'all, is 82.3 degrees. Okay. All right. Now we need to find the value of little c. So how we're going to find the value of little c? We're just going to use the law of sines. So little c over the sine of c is equal to little a over the sine of a. Little c over the sine of c we just found to be, what, 82.3? Is equal to little a, which we already knew to be 16, over the sine of 45. And again, I'm going to multiply both sides by the sine of 82.3, okay, to get rid of that. Okay, so let's go 16 sine of 82.3 divided by sine of 45. Okay. And I'm coming up with 22.4. So right here, this is 22.4. Okay, so look, y'all, I'm going to come back over here. So, oops. So I'm going to come back over here, right? Do we have one triangle or do we have two triangles? I don't know. I know I've already found one triangle. I'm going to check to see if there's a second. So let me show you how we're going to check to see if there's a second. Do you remember when we were doing our problem right now? The first thing we did is we came up with that number right there. We came up with B being equal to 52.7. Okay, so that told me that my angle was a positive angle, right? What is the sign positive? In which quadrants is the sign positive? 1 and 2, right? So it's possible that we could have a second triangle in the second quadrant. The way we would figure that out, I'm going to call this, I'm just going to make this up. I'm going to call this angle B2. I'm going to take 180 and I'm going to subtract off the angle that we found, which was 52.7. So 180 minus 52.7, that would give me 127.3. Okay. So my second angle would be 127.3. Now, to see if this is actually going to work, remember what my angle A was from the very beginning? My angle A was 45, right? If I take those two angles and I add them together, I have 172.3. Remember my angles, y'all? Everything has to add up to how much? 180. So that would tell me that, say, my angle C2 would be 180 minus that 172.3. So my angle C2 would be 7.7 degrees. And then we could find, say, like the little C2 by saying, let's take the sine as 7.7 degrees is equal to little a, which I want to say was like 16 or something like that, right? Yeah, 16 divided by the sine of 45, and we'll multiply everything by the sine of 7.7 degrees. And for my little c, I'm coming up with 3.0, I guess. Okay. So we actually have two triangles here, okay? And y'all, I'm going to go back and do number 7 so that we can understand, hey, how do I know when I have two triangles or not, right? Because here, like, you're able to figure out that we did. I'm going to show you, I think you said that probably in number 7 there was only one. So I'm going to kind of show you the idea. So look, we're going to come back over here, and we're going to say we have two triangles. So in the first triangle, let's see, we got 52.7 for my angle B, 52.7. What do we come up with for our angle C? I already forgot. 82.3, it's right here. 82.3, and then little c was 22.4. Okay, 22.4. And then in the second triangle, we got our angle B to be 127.3. 27.3. And I want to say angle C was like 7.7. And then side C was 3. I'll put 3.0. Okay, so let me go check, and let's see what happens. Did we get it? We got it. Okay, so excellent question. So look, let me come back and let me show you number 7, and I'm going to show you the process. So again, we understand how can I find out if there really is that second triangle, okay? So look, y'all, I'm going to do number 7. I'm going to do it exactly like the way we did number 8, okay? And just give me 1 second, John, and then I'll get you, okay? But I will, I promise I will get you. Okay, so look, let's come back over here. paste this guy in. Okay, let's zoom in. Okay, so first thing we're going to do here, it says determine we have one triangle, two triangle, no triangle. Okay, so I'm going to just draw a little basic picture. I don't know what it's going to look like, something like that. Okay, so my angle B is 38 degrees, and the side B is 32, and the little side C is what, 24? And I don't know what the angle A is, I don't know what the angle C is, and I don't know the value of little a. Okay, so let me ask you a question. What angle should we be looking for, say, first? C, right? Because we know, we at least know the side of C, right? So do y'all agree that we could do something like this? Say the sine of C over little c is going to be equal to the sine of B over little b. That would be how I would kind of start this off. Okay. And then let's see, let's go ahead and write it over here. So the sine of C over 24 is equal to the sine of what, 38 degrees divided by 32. And then we're going to multiply both sides by 24. Okay, and then to find C, we're going to take the sine inverse of all this business right here. Okay, so let me grab my calculator. And first thing I'm going to do, I'm going to type in second sine inverse of 24 sine of 38 divided by what, 32? Okay, and I'm coming up with 27 point, I would say 27.5, right? Okay, 27.5 degrees. Okay. Then, now that we have this, y'all, we could find the value of angle A, we could find the side little a, right? I think we know how to do that before. How do you determine if there's a second triangle? With the first angle that we found, which was this one right here, look what it said. We used the sine, right? And I know sine is positive in quadrants 1 and 2. So I would have to ask myself, look, is it possible that I could have a second angle in quadrant 2, and it would be 180 minus, what did we just get? 27.5. So if we did that, if we said, what's 180 plus, I'll put negative 27.5, put a plus there. Okay, so that would tell me that my second angle would be 152.5 degrees, right? What was our angle A that we started off with? You remember? My angle A was what? 38, right? That's right. And if we added those two numbers, that would already be more than 180 degrees, right? Yes. That's right. So think about this, y'all. If you look at this problem and the other problem, in this problem, the first angle we found was angle C, right? So if we're going to figure out if there's a second one, whatever number we just got, we're going to subtract 180 from that number. That's going to tell me, is it possible that I have a second triangle? If you look, I'm sorry, real quick. If you look in the one that we did before, the first angle that we found was B. It was 52.7, right? So that's right. So we said, look, let's take 180 minus that. And that's telling me that it's possible that I might have this angle. And with this one that we're already given, yeah, it's going to work because both of them added up together is less than 180. Does that make sense? John?
I understand, like, I just cannot see outside. And that's really important. Just to remind you, how would these two triangles look like on the graph?
Okay, so remember, you can draw two separate triangles, right? You don't necessarily need to draw one triangle imposed on another one. You know what I'm saying? You don't have to have one triangle here and the other one.
Well, but they're still coming off the same graph, right? Like,
well, but not necessarily, because now I have two triangles, right? So look, if you're talking about problem number 8, where we have the two triangles, right? Okay, so look, let's do this. We have angle A to be 45 degrees. So look, I'm going to draw a triangle, and I'm going to say this angle here is 45 degrees, right? And then we got angle B to be 52.7. So I'm going to make this look something like this. So here's my angle B, which is 52.7. My angle C is 82.3, right? And then I can label the sides. Does that make sense? So far we're good? Okay.
Which one is the one that's going to be coming out from the, what is it, boarding, like the setup point? Which line would it be on your base? Because you're subtracting one, right? On the other side?
Yes, okay, but so remember, this was my first triangle, right? So all I did is draw a triangle with those angles there, right? And I can label the sides too, but that's what that triangle is going to look like. Now, look at the second triangle. So first thing I'm going to do, and this is roughly what I'm thinking of. Like this is 45, this is 45, and that's 90, right? So just so that I get an idea, like how do I draw my triangle, right? A 45, 45, 90 triangle looks something like that, okay? But look, this is what we're going to do. We're going to put a line right here, and we're going to say that's 45 degrees, right? Look at the other angle C. The angle C is really, really, really small, and the other angle B is like massive. So if I wanted to make an angle that was really, really, really small, let's see if I can figure that out. So that's 45. Let's go like this, and it would have to be something like, oh man, I want my angle B to be massive. So look, I could do something like this, and maybe something like that, and I'm going to kind of cheat a little bit right there. But here's my angle B, which is 127.3, and here's my angle C, which is 7.7 degrees.
And you got the 127
By subtracting the first angle that we found over here, I subtracted it from 180 because sine is positive in quadrants 1 and 2. So think about it this way. I'm going to extend this a little bit, right? Wouldn't this angle right here have to be that 52.7, right?
And this time you also know that that angle, that length of that side is the same because of the dimensions of it.
Yeah.
I get it.
Yeah.
It's just hard for me to.
Yeah, so remember, the process, so y'all, and how I'm going to do this is once I find my first angle, subtract it from 180. If you can form a second triangle, you'll have one. If you can't, then you only got one triangle, right? So good questions, y'all. Good questions. Okay, let's keep moving along here. What about number 9? I don't know if anybody's got any questions for number 9. Do y'all know how to do the area problem here? I think this is finding the area, right? So wouldn't we use, what is it, like Heron's formula, right? And so y'all just, again, just to kind of pull that up, that should be somewhere in here. Here we go. Here's Heron's formula for area of a triangle, right? And you find that semi-perimeter where you take all the sides, add them together, and then take half of it. Okay. All right, let me keep moving along here. Yeah, is it doing it again on yours? Okay. It was it. Which one was it? Was it the one with the angle, the triangle?
This Monday's homework? It was just a simple question, I guess.
Okay. So do me a favor. Can you send me a message on Prana, and then let me know what question it was, so I can go and fix it for you. Okay, appreciate it. Yeah. Sorry about that. Alex is, I don't know. I know John was asking about this the other day because it did the same thing and marked one of his problems incorrect, and it actually gave him a explanation that was not even correct at all. I don't know if it's because this is the first edition of the book, why there's these kind of errors. But if anything like that happens, y'all, just take a picture of it. Let me know what problem it is. I've yet had the same thing happen the other day. It counted his problem incorrect, and he had it correct. So if anything like that happens, y'all, just let me know. It's not a big deal. I'm happy to fix it for you guys. All right. So look, y'all, I'm just gonna kind of keep scrolling on. I want you guys, y'all need to be the ones to let me know which ones you want me to go through, okay? I'm sorry, which one? 23, okay, so let's scoop all the way over to 23. This one here? Okay, so let's go through 23. Okay, so I'm going to do a little copy and paste right here. Okay, so let's make a copy. And again, y'all, if you have any questions, just let me know. Okay, so let's go through here. Okay, and then y'all, the first thing I'm going to do, I'm going to go to my formula sheet and I'm going to look for where do we have our roots. And let's see. Here we go. Here's how we find the roots of our complex numbers. Okay, so the second thing I'm going to do, we'll copy and paste from right here. Okay, copy this one. Let's come back over here and let's do a little paste. Okay, so it says, find the indicated complex roots, write their results in polar form, give exact answers, and then list the roots in increasing order of theta for theta between 0 and 2 pi. Okay, so look what it is we're trying to find. We are trying to find the square roots of this value right here, okay? So, look, y'all, I'm going to write out the general formula. Oh, you do it in black. Let's go back over here. Okay, so I'm going to go WK is equal to the square root, because we're talking about square roots, of my number R, which is 9, times, let's see, the cosine of theta. Theta in this case, y'all, is 7 pi over 6. So I'm going to put 7 pi over 6 plus 2 pi k. All of this is over n. Since we're talking about the square root here, y'all, my number n is going to be 2, right? Plus I sine of the same thing, right? I sine of 7 pi over 6 plus 2 pi k. All of this is over 2. Okay, so I'm going to keep working here. First thing I know, square root of 9, I know that's 3. That part's easy, breezy, cover well to do, right? Okay, so look, remember what this means here? When we're dividing by 2, y'all agree that dividing by 2 is the same thing as multiplying by 1/2, right? Okay, so look, I'm going to just do a little erase, 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 and I'm going to do this by 1/2, okay? So look, if I go slow, 1/2 times 7 pi over 6, y'all, is going to be 7 pi over 12, because I multiply fractions straight across, right? Half of 2 pi k, well, this 2 and that 2 are going to cancel. That's just going to give me plus pi k. It's going to be exactly the same thing here, except it's with the sign. That's right. And we're going to go ahead and do this, figure out all this business. Okay. So I'm just going to kind of zoom out here, y'all. If you notice, we have 2 values here, right? One of them is W0, one of them is W1. We're going to do this because we're talking about the square root. We're going to work from 0 all the way up to the root before whatever root we're taking. So if we were doing the cube root, we'd go k is 0, 1, 2. If we were doing the 8th root, we'd go k is 0, 1, 2, 3, all the way to 7, okay? So since we're dealing with the square root, we only got to do 0 and 1. So all I'm going to do now is, this is kind of like my formula. And I'm going to say, okay, what would W0 look like? It would look like 3 cosine of 7 pi over 12 plus pi times 0 plus I sine 7 pi over 12 plus pi times 0. Okay. And we know that pi times 0 is 0, so that's going to go away, and that's going to go away. So W0 is going to look like this. Okay. Now, we're going to do the same thing, but now k is going to be equal to 1. Remember, k is equal to 1. So I'm just putting in the 1 right there. So pi times 1, just pi. And let's see. All right. Y'all, can I do this 12 pi over 12 so that we can get our common denominator? So 7 and 12 should be 19. Okay, good. 19 pi over 12 and I sine of 19 pi over 12.
So, what's this form called again?
De Moivre's theorem?
No, but we're going right in this form.
Oh, this is in complex form?
Complex form.
Yeah.
And so you should also write it as 3,
Yeah. Yeah, you can write like that too. That's still complex form. That's just using like the abbreviation. Okay, so look, y'all, we got two answers. Here's the first one right here. So W0 is 3 cosine 7 pi over 12 plus I sine 7 pi over 12. So let's come back over here. All right. So I'm going to go 3. I'm going to go parentheses. Do we got print? I guess we got to put them ourselves. Cosine. What is the one we got here? Cosine of, let me get my fraction bar. 7 pi over 12. Oops. Plus, let me go plus. There we go. Pi sine fraction bar 7 pi over 12. But for the first one,
Oh, yeah, so that's the last.
right, we were 7, and then the second one will be 19. Yeah, you're good. You're good. Don't worry. It's okay. Let's see. Okay, and then close my parentheses. All right, and then the second one here, same thing. Parentheses cosine of, where's my fraction button? 19 pi 12 plus pi sine fraction bar 19 pi over 12. Close it. Check it. Boom. There we go. Jennifer, better? Yeah? Good, 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 good. All right. Any other ones? Let's see. I don't know if anybody's watching at home. We got a couple people watching at home. Thomas is watching, and Luciano. If y'all got any questions, y'all, you can throw them in the chat box right here. So, oops. All right. And let's come back to our, here we go. All right. Anything else, y'all? We did number 8. And then we said, let's take a look at number 9. Then I said, okay, anybody got a question? Jennifer said 23. So I went to them. Right? Okay, so let's take a look. So let's go like this. Okay, so let's go copy, and let's come back over here, and let's paste this guy in. Okay, so it says, solve the triangle subject to the given conditions possible, round the lengths of sides and measures of the angles and degrees to 1 decimal place, round intermediate steps to at least 4 decimal places. Okay, so we're looking for little a, angle B, and angle C. Okay. Very, very much like that, yeah. And so let's take a look here. What do we know? I'm going to draw a real simple triangle. So it's going to look maybe something like this. Here's my angle A to be 106 degrees. I don't know the side little a though. And we know that say side little b is 804.9. And we know that side C is 435. I don't know the value of angle C, and I don't know the value of angle B. Okay, so it's going to be really difficult for me to use the law of sines because even though I have angle A, I don't have side A. And even though I have sides B and C, I don't have angles B and C. So we're going to go with the law of cosines here, y'all. So look, let me scroll back down over here. Let's find our law of cosines, and here we go. Okay, so let's take a look what we got. I'm going to come back to my picture one more time, and I'm going to say, look, you know what? Why don't we first find the value of little a, right? And if I use right here, it says a squared equals b squared plus c squared minus 2bc cosine a. So I'm going to say a squared equals b squared plus c squared minus 2bc cosine of my angle a. Okay, so a squared is equal to b squared, 804.9 squared, plus c squared, 435 squared, minus 2 times 804.9 times 435 times the cosine of 108 degrees. Okay. So again, here, y'all, this is going to be calculator type stuff.
And there would be literally no way to find out little a because we're not doing little a.
That's right. That's right. Okay, so look, let's go super slow. 804.9 squared plus 435 squared minus 2 times 804.9 times 435 times the cosine of 108. Okay, and this is the value I'm coming up with, y'all. Notice that's actually giving me the value of a squared, though, right? So if I want to find a, I need to take the square root of what we just came up with. Okay, so I'm going to go second square root of my answer, and I'm coming up with 1026.3928. Okay, so a equals 1026.3928. And the only reason I'm going 3928 is it said, whatever you're going to do for your intermediate steps, round to 4 decimal places, so that's what I'm doing. Okay. All right, so now that we found little a, we can probably find the angle for, say, either for angle B or angle C, right? Because now we know that this side here is 1026.3928, right? So now I can go back and I can start using, say, law of sines to say find the angle for B, okay? So look, let's do it like this. You can say the sine of B over little b, which is 804.9, equals the sine of A, which was 108 degrees, divided by the 1026.3928. And I'm just going to multiply everything here, y'all, by 804.9 to get rid of this guy. So 804.9 times the sine of 108 degrees divided by that 1026.3928. And then to find my angle B, we're going to take the sine inverse of all this business right here. I'm sorry? What do you mean? Okay, so I'll tell you what, let's do this first, and then you can, okay, so let's go 804 0.9 sine of 108 divided by that 1026.3928. Okay. And what I'm coming up with B, y'all, is 48.2297. And again, I'll figure out how many decimal places I'm supposed to go to, but it had said for intermediate steps go to 4, so that's what I'm just doing for right now. 48.2297. Okay. $48. 2297. Okay. And so now let me come back over here. Okay, it wants me to round everything to 1 decimal place. So that we can do pretty easy, breezy, cover girl. So for side A, y'all, if it's 1026.39, I'm going to say this is going to be 1026.4. For 48.22, it's going to be 48.2. And then we can find angle C by just taking 48.2, adding 108, and subtracting them from 180, right? Oops, let me move this guy over. So let's see, 48.2 plus 108 is 156.2. So now I'm going to go 180 minus my answer. And I'm coming up with 23.8 degrees. And that was also degrees. So when I come back to my problem, let's see. For A, 1026.4. 1026.4. For B, we got 48.2. 48.2. And for C, we came up with 23.8. 23.8. And we'll chickadee check. Oh, no. Why not? What did we do wrong? Let's see. What did I do wrong here? Did I write my numbers right? You know what? Let me see. Did I use 804.9 is one that I used, right? Oh my goodness. Why not? All right, let's see. 1026.4. Did I write something wrong down? Ah, okay. You know what it is, guys? What was angle A? What did I write? 108. Be careful with what you write. Okay. Oops. That was my mistake. Okay. And the reason being, when I looked at right here, I saw 108 because of my little degree symbol. Oops. Okay, so let's see. Angle A, boom, 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 106 degrees. Okay. All right. So it won't take much to fix it, y'all. We'll fix it real quick. Okay, so give me 1 second. Let's go back and fix it. 804.9 squared plus 435 squared minus 2 times, let me do parentheses, 804.9. Yeah, so I'm guilty of this too, y'all. I write messy and I look at the wrong number. Cosine of 106. Oh my, not 108. Okay. And then second square root of my answer. Okay, so I'm coming up with 1014.9422. Okay, so let's fix that real quick. 1014.9422. Right here, this is going to be a 1014.9422. Okay, so that should be able to fix this part here, because then I'm going to come back over here, and this is not 108, this is 106. And oops, And this number down here is actually 1014.9422. Okay, so let me fix that over here as well. 106. And 1014.9422. And again, one more time. 106. And otra vez over here. 1014.9422. Okay, so let's try that part right there. Let's move this guy over. Okay, so we're going to go second sine inverse of 804.9 times the sine of 106 divided by 1014.9422 equals, okay, so look what I'm coming up with now, 49.699, and I think we were going to one decimal place, so I'd say 49.7. Okay, so let's change this guy here to 49.7 degrees. And so I'm going to come back over here, y'all. I'm going to fix a couple of things. So let's see. A is 1014.9. B is 49.7 degrees. And let's figure out what angle C is. So 49.7 plus 106 is that number. And 180 minus my answer is 24.3. Okay, so now let's see if we can fix this. 1014.9. B was 49.7. And C was something. 24.3. And let's go recheck. Boom. All right, there we go. Much better. Okay. So, yeah, I'm guilty of it too, y'all. But you can see, really, what am I doing? All I'm doing, y'all, is the first thing when I did this problem, I drew the picture, right? And then once I drew my picture right here, I said, look, can I use the law of sines? No, because in order for me to use the law of sines, I have to have the angle and the side opposite. And we had the angle, but we didn't have the side opposite. And then we had these sides, but we didn't have those angles. So that told me, hey, the only other option I got, bust out my formula sheet and use law of cosines, right? So that's how I'm able to figure out the stuff. But I'm going to be using one of those two formulas. And what's helping me so far, draw my picture, right? Draw my picture. I can figure out exactly what it is I'm trying to do. You could have done that too. Well, but remember, what was I first trying to find? Was I first looking for an angle? You can do that too, but let me ask you a question. Does this look simpler than the law of sines? You know what I mean? I mean, we could have done that. We could have used that form to find one of those other angles, but this right here is more complex than doing that, isn't it? And if you can get to the same spot without having to do as much calculation, I would do that. But I mean, if you want to use the other forms, you can definitely do it. You should come up with the same answer. It's not like you're going to get a different answer. It should still work. All right, good. Let me see. Did any of the questions in the chat? Okay, so let's come back here, and we'll just keep moving along. Find the area, right? That's straightforward. Using Huron's formula. This was the one that you were talking about, right? Was it this one? No, yours was the vector one, right? Yours was one of the vectors. Okay. And you sent me a message already? Okay. Don't forget to send me the message so I can fix it. All right. You guys are all good with these? Finding like how to plot the polar stuff? Converted from polar to rectangular? We good? Anybody want me to go through this one? If you guys want me to do it, we're good? Just checking with you guys. How do I go back from rectangular to polar? Get so far. How to plot complex numbers, imaginary plane. Pretty straightforward. Do the modulus. We know how to find the modulus, right? Just the square root of a squared plus b squared. Any questions, y'all? I mean, I can just kind of keep scrolling through, but if there's something that you know you had, I definitely want you to let me know. Rectangular form, polar form. And so, like, if you're going to do something like this, y'all, again, if you bust out the formula sheet, where is it? Right here. Tells you how to multiply and divide complex numbers, right? So I really try to give you guys like all the formulas that we put, right? I just kind of put them in one document, but it's all right there. So I definitely encourage you, make sure you have the formula sheet. And then y'all, real quick, I'm going to come back over here. Where is it? In the announcement, I also put the trig functions of special values so that you can use this one as well, right? If you need to, but you definitely have that access to that as well, okay? Anything? You guys, let me ask you a question. On level 1 to 10, 10 being like, I think I'm going to make an A on this test, and 1 being like, I wish I was somewhere else. How do you guys feel? Good? For the most part, good? Anybody feel like less than a 5? Use what you got, right? Use what you got. Use the notes, use the reference, right? No, so the test has 17 questions. And so what I did is, like, when I went to the review, right? Like, here's the review, and I saw this problem, right? I was like, I like this problem. What problem was this? And this problem was, this has to come out as 7.4. I think it's where this problem came out of. I think it's 7.4, right? But whatever problem it was, so what I did is I made a list. And when I made my list, I said, these are the problems that I'm picking from 6.1, and these are the problems I'm picking from 6.2, 6.3. You know what I mean? That's how I did it. And I picked these problems specifically, right? But like say, okay, look, like we did 23, right? Where was 23? This one here. If I hit try another, okay, it's still giving me square roots. The only thing is different is what happened. My R changed and my angle changed, right? But isn't it basically the same type of problem? Right? So if I know how to do the one that we did earlier, the one that Jennifer asked me about right over here, then I can apply that same principle to this one here, right? And I'm going to say, okay, I know how to do this one. That's really what I did, right? So that's why I say, and guys, even in my other classes, I know you guys are already out of college algebra, but in my college algebra, that's what I did. Like, their review had 42 questions, and the test has 20, and I picked questions from those 42. I picked 20 out of those 42. So with this one here, this review had 33 questions, and I picked 17 of them, right? So I picked it just like that. And then let's see. I don't know, y'all. I'm just going to keep clicking, and if there's something that catches your eye, you tell me. And if nothing catches your eye, then that's it. This is probably easy breezy cover girl right here, isn't it? How do I add 2 vectors? I hope that's one of the 17, something like that. Or this one here, how do I subtract 2 vectors? I hope that's one of the 17. I made the test last week, y'all, and again, I just, all the questions came directly from here. There's no surprises, okay? It's not like you're not gonna see a question on the test, it's like, sir, that question wasn't on the review. It came directly. And so y'all, I guess we don't have any more questions because I'm not hearing anything. So I am gonna stop recording the session. Those of you